Hello class, welcome to 5.3B Graphing Linear Inequalities. When we graph linear inequalities, there's going to be three main things we need to look for. The first one is to graph the line, which we handle differently, whether it's in slope-intercept form or if it's in standard form. When we determine, once we have that line graphed, the next step is to determine whether it's solid or dashed. So anytime you see something with an equal sign, that is when we're going to be looking for solid lines, because that is going to tell that those answers or those points on the line would also be included as part of our solutions. When it is a dashed line, so it's not equal to, they would not be part of our solutions. And then lastly, we want to figure out which way to shade our graph, which is typically going to be best by picking a test point. All right, so any point if possible, but the one if we want to look at 0, 0 if it's there. And then of course we want to shade the true side. So if it's true, that's the shade we side. When it's false, you have to shade the opposite side, because there's only either true or false. And then lastly, if you're looking at your just in the y equals mx plus b or less than or anything like that, then we can use this little cheat, which would basically be the shade under if it's less than shade above. But that only works for slope-intercept form. All right, so let's look at some examples. So when we start with a graph that's in slope-intercept form, remember we are looking for our y-intercept, which is -2, and our slope, which is 3, so that's going to be a rise of 1, or rise of 3 over 1, up 3 over 1, which also means it could be down 3, back 1. Once you establish these points on your line, we want to look at our inequality and figure out that this is dashed or solid. When there is no equal sign, that is going to tell us this graph should be a dashed line. And then the last thing we're looking for is, are we going to shade above or below? So looking at a test point, we're going to pick 0, 0. So we're just trying to establish whether or not the point 0, 0 is true or false. So when we plug this in, now we are plugging in for x as well. So a lot of times we don't necessarily show that step, but is 0 greater than -2? This is true statement, so this is also going to mean that that point 0, 0 is on the true side, which means everything over here would be false. And then what we're looking to do is shade any of those solutions on the true side. Now this is really telling us that any point on here, we could pick a -2, 4. We could pick a 4, -2. We could do -2, -3. All of these points in that red shaded area would be solutions. We could not include, now even if we're looking at some of these points here, like if we tried to go onto our line, because this is not shaded or not equal to, they would not be part of our answers. Okay, looking at our next one, start at our y-intercept of 2. Our slope is down 1 over 4, which means up 1, back 4. This one now does have a equal sign, so that is going to be a solid line across there. And then we want to test out our point 0, 0. So if we test out our 0, 0, this is going to leave us with 0 is less than or equal to 2, which does appear to be true, which makes this true, going to make up here false, and that's going to leave us with true, anything below our graph. Now again, we did kind of talk about the special case, when they are in y equals mx plus b, that less than symbol is going to tell us it's going to stay below the line. And over here in example 1, that greater than says above the line. So we'll keep that stuff up there. All right, let's take a look at standard form. When our equations start, or inequalities start in standard form, This is where we typically want to take a look at finding our x and y intercepts. So what we're looking at, well, when does x equal 0? When does y equal 0? So plug in, and 5y equals 15, divided by 5, and y equals 3. So that means we have the point 0, 3 up here. If y is equal to 0, that means 3x is equal to 15, and we're going to divide by 3. So x is equal to 5. So we have 5, 0. And again, once we get these 2 points, we're going to be looking at the fact that this is not equal to. So we're going to want to draw with a dotted line. And then we're also going to want to take a look at our test point, 0, 0. Because now at this point, we can no longer trust which way that line is going to graph. So we want to test out 0, 0. Which is going to say, is 0 greater than 15? That would be false. So that's going to make everything down here false, everything up here true. And make sure we are shading the true side. When we look over here, same deal. If x is equal to 0, that means negative 7y equals 28. Which if we divide by negative 7 is going to be y equals negative 4. So y equals negative 4. If y equals 0, that's going to be negative 4x equal to 28. So if we divide by negative 4, x is equal to a negative 7, which looks like we're a little bit off of our graph here. Now this one will be a solid line. And then of course we want to do a quick test. And always use 0, 0 if possible. So is 0 going to be less than or equal to 28? That does appear to be true. So that's going to tell us shade above. And again, once we look at all of these, this is just to help us figure out that anything up here in the red shaded, this is our true section. Anything down here in the blank, that would be false. They would not be solutions. And lastly, we take a look at the horizontal and vertical lines. So the first thing we need to remember is, how do we graph y equals negative 5? So I always remember this by saying, well, where is y equal to negative 5? And that's going to be anywhere along this horizontal line. Once we have that line drawn, same things apply. So we're looking at solid or dashed. In this case, it is not equal to, so it will be a dashed line. And we can still use our test point of 0, 0, basically saying if we plug in 0, is that going to be greater than negative 5? Well, that is true. So anything up here is true. Anything below would be false. So we want to shade any of these points above the line. When you look at x is less than or equal to 3, well, where does x equal 3? This is anywhere on that vertical line. And then we look at solid or dashed, and because it does have an equal sign, that is going to be a solid line. And then lastly, our test point. And this one here, if you're looking at 0, 0, is 0 less than or equal to 3? That is true, making that our true side, this our false side. And we want to shade anything that is less than 3. Okay, that should be it for today's lesson. Make sure you have that worksheet finished up, and make sure you're ready to go tomorrow. Have a great day.